you know the unit of pressure is megapascal. In higher unit, simple unit is pascal, megapascal means 10 to the power 6 pascal, and it is after conversion of the heat into mechanical energy. Now it will be coming to 1 pascal only, 1 megapascal. You see how much efficient is your turbine. So, that exhaust stream again condense in the condenser. That means condenser gives again water, that is known as condensate. So, how? Now, in the condenser there is a condenser coils, you know, like that you will reject heat to the, here the pressure also and temperature also high, it gives heat to the cooling medium, that is your water. Water is also a must in power plant. Water should be available plentifully near the steam power plant. That means there should be a source like river or ocean from which you will get water, and that water after treatment they will enter into the condenser, where the steam will reject heat to the water, and that the water will gets heated and it will again enter into a cooling tower. You will find a cooling tower where the warm water coming from the condenser gets cooled, and so that the water again reused for getting heat out, taking heat from the steam in the condenser. So, this is one another unit, that is a cooling tower, and this is a circulating pump. You know, pump always circulates, it never stops, it will continuously circulate the cold water coming from the cooling water to the condenser, and in the condenser that water gets warmed by taking heat from the steam, and then again it is enter into the cooling tower. So, here we will get the production of cold water is produced. Again the condenser the liquid, and that is water. The water is here, you will get the liquid water will get, not steam. Water will supplied to the boiler by the condensate water pump, that they are all centrifugal pumps. So, they will handle liquid, and that liquid before going to the boiler, here is an economizer. Economizer means here the waste heat of the boiler can utilize by economizer. So, the waste heat coming from the boiler, here is the coal is get heat energy from the combustion of coal. We are just getting heat input to the boiler from the combustion of coal. Total heat is not utilized, some heat is remains, that heat is utilized through economizer before entering to the boiler. So, that this water will gets heated, so that boiler in the boiler efficiency will increase. So, less coal is required. So, through economizer it gets heated water, then a boiler then again it is converted into steam. So, then this cycle is one cycle is completed. Similarly, so number of cycles are completed. So, we get continuous supply of electricity to the citizens. So, this is the working of steam power station and the layout. And the boiler, you know, the boiler exhaust are ash is produced, you know, in the coal, when coal is solid fuel is burned, we get ame so paunso pandi ash handling, that it may go to the atmosphere. The atmosphere, if you will see, you will get in the trees of the nearby steam power plant, their leaves are coated with ash, and if you will go there also, your body will be fully ashed. Therefore, nowadays that problem is eliminated by one precipitator, that is electrostatic precipitator. It is called ESP, electrostatic precipitator, where the dust are ionized and they are collected by electrodes. So, only gases are solid particles remains and the gases are goes through the chimney. This is your chimney, which only gases are allowed to the atmosphere. That means it is the pollution free. Another air filter, its work is, combustion will takes place when oxygen is available. That means oxygen is only available in air. So, therefore, the air supplied to the boiler, that is heated air, preheated air. That means heated air only allow to the boiler, so that your less fuel is required for the combustion. That it is one advantage. So, air preheater is also in the part of the boiler. So, minimum parts I have shown in the layout of steam power plant. Another, if you detail go on ash handling unit, so various complicated things are there achieved, but it is simplified layout. Almost all parts are shown here. Only this turbine you will find high pressure turbine, nozzle, steam turbine, intermediate, low pressure. So, we will go on in the next slide. We will see how the this can be modified by reheating, regeneration. Now, we will go to the next. Next is 2.2 steam power cycle as per syllabus of your 6th semester. So, nowadays it is a compulsory subject. Earlier it was a elective, but from this new revised syllabus it is your compulsory subject. So, in this is Carnot cycle. It is a very known cycle to every student from the beginning of the branch 3rd semester. It is already discussed. So, it is very common thermodynamic cycle, or which is one is the only purely theoretical cycle. Carnot cycle is not the practical cycle. It is only read for to get the idea. From that Carnot cycle, other cycles are modified. That means Carnot cycle modified to other cycle known as Rankine cycle, where Brayton cycle. These are the thermodynamic cycles. So, we now read power plants work on the basis of some thermodynamic cycle. That means every power plant, it may be gas power plant or a diesel power plant, nuclear power plant, steam power plant. So, in every power plant there is a thermodynamic cycle. That means thermodynamics behind the power generation. So, the first one is Carnot cycle, next is Rankine cycle, another is Brayton cycle, also diesel cycle. Brayton cycle is used in the gas turbine power plant. Rankine cycle is the thermodynamic cycle for our steam power plant, where the coal based steam power plant or your nuclear, same thing, thermal power plant or a steam power plant. So, Rankine cycle is the thermodynamic cycle. Remember, Rankine cycle is the thermodynamic cycle of steam power plant. Carnot cycle is an ideal and most efficient cycle, but it is not practically feasible. Clear? Carnot cycle, you know, is developed by Nicholas Leonard Sadi Carnot, very old cycle. That cycle is an ideal cycle, but and most efficient, but it is not practically feasible. माने ता द्वारा कौन सी प्लांट तुम बने पारिबो नहीं, कारण कैनर साइकिल रे बहुत प्रोब्लेम माने ये अच्छी डिफिकल्टी अच्छी जोटा कि इम्पॉसिबल माने सेठी अच्छी तो हमर पंप पंप अच्छी जे से केवल हैंडल आम जान पंपटा हैंडल कर ओनली लिक्विड बट कैनर साइकिल पंपटा काम कर बोथ फ्लूइड liquid and vapor which is impossible. That means only the pump only handles your liquid only, but in Carnot cycle that is shown in the diagram. I will show you that it handles wet steam which is not possible. Therefore, that part is modified in Rankine cycle. Next, coal based power stations use Rankine cycle. Clear? Efforts are made to bring Rankine cycle efficiency close to Carnot cycle efficiency. So, हम जानिले जे coal based power station रे सबू Rankine cycle use होची. Efforts we are trying, so that cycle efficiency should be close to Carnot cycle efficiency, because Carnot cycle efficiency is the maximum efficiency you can obtain from the heat. So, therefore, our effort is Rankine cycle efficiency should close to the Carnot cycle efficiency. Next, this is a reversible cycle. This is a reversible. You know reversible cycle. What is the? They are reversible adiabatic, reversible isothermal. These are the processes. Therefore, it is a reversible cycle. Ideal cycle, no friction. It is a static process, quasi-static process. The cycle consists of two isothermal processes and two reversible adiabatic processes. So, remember it is there is 4 processes. The cycle consists of 4 processes. 2 is isothermal, another 2 is reversible adiabatic processes, or they are also known as isentropic processes. Isentropic is a reversible adiabatic. Reversible adiabatic also known as isentropic process. Isentropic. Or constant entropy process. Constant entropy. You know entropy in the earlier semester. Entropy is a thermodynamic property. Symbol is S, capital S, or specific entropy small s, and that unit you know kilojoule per kg Kelvin. So, this is the unit of entropy. Constant entropy or isentropic process, that is called as also reversible adiabatic. Adiabatic you know, adiabatic means heat transfer is 0. Adiabatic. Adiabatic means heat transfer, heat interaction Q is 0. Heat transfer is 0. That is called adiabatic. If it reversible adiabatic, that means no heat transfer. So, that is entropy remains constant. Next slide is the this one. Next slide is your Carnot vapor power cycle. Now, you call it as Carnot, instead of Carnot cycle you call Carnot vapor cycle, because here vapor is your working fluid flowing through this total cycle. So, आरो मार्क दिया है बॉयलर, बॉयलर जाउची स्टीम टा वेपर जाउची टर्बाइन, सी टर्बाइन, टर्बाइन जाउची कंडेंसर, condenser जाउछ compressor, compressor again boiler. So this is the 4 processes. 2 isothermal माने heat addition, एटी बॉयलर रे हीट एडिशन होची तुम जानछ बॉयलर रे हीट ऐड करा जाए, हीट इनपुट करा जाए, एटा कांस्टेंट टेम्परेचर रे हबो, सो इट इज कॉल्ड योर आइसोथर्मल. सेमती हीट रिजेक्ट हुए कोडी ना कंडेंसर रे, दैट इज आल्सो कांस्टेंट टेम्परेचर और आइसोथर्मल. आइसोथर्मल मीन्स कांस्टेंट टेम्परेचर. रिमेंबर, आइसोथर्मल मीन्स थर्मो माने टेम्परेचर, आइसो माने सेम. सो टेम्परेचर before and temperature after process they remain same both in boiler and condenser. This is your high temperature and it is low temperature. If you will compare to a heat engine, so this is the source and this is the sink. You know, any cycle or any machine engine is only possible as per Kelvin Planck statement in Kelvin Planck statement in second law of thermodynamics. Kelvin Planck statement as per Kelvin Planck statements in the second law of thermodynamics, that should be some heat should be rejected. Some heat should be rejected into the sink. That means 100% heat cannot be converted to work as per your second law of thermodynamics. So therefore, condenser is your sink, it is a source. Here some heat is always rejected. So otherwise, if there is no heat rejection, the plant is impossible. So turbine, you know turbine, I have already discussed in the layout. Boiler, turbine, condenser also discussed. Compressor. Compressor means here it is, that is instead of a pump, it is known as compressor. कंप्रेसर काम है प्रेशर बढ़ेवा आउ क्वांटिटी भी सप्लाई करवा. पंप भी सैया ऑलमोस्ट दे आर सेम. पंपटा केवल हैंडल कर सिंगल फ्लूइड हैंडल कर किंतु कंप्रेसर ये से दुईटा फ्लूइड हैंडल करी ता नाटा कंप्रेसर कराई. कंप्रेसर माने तुम वॉल्यूमटा रिड्यूस होइछि. देखो टर्बाइन रो साइज आउ कंप्रेसर साइज देखो डिफरेंट रिवर्स. एटा आर एरियाटा बढ़ी बढ़ी जाइछि. सो एक्सपेंशन दैट इज कॉल्ड टर्बाइन माने एक्सपांडर. वेयर एक्सपेंशन टेक्स प्लेस देखो कंप्रेसर रे तमर एरियाटा कमी कमी जाइछि माने एटी वॉल्यूम कमिछि, प्रेशर बढ़िछि. टर्बाइन उल्टा प्रेशर कमिछि. प्रेशर टर्बाइन प्रेशर कमाए से ता कहते एक्सपांडर बा एक्सपेंशन हला. कंप्रेशन माने प्रेशर बढ़िला माने कंडेंसर प्रेशर रु आमे बॉयलर प्रेशर रु गले. So this is the your mechanical arrangement of the Carnot cycle. Mechanical arrangement. So mechanical means they are, since they are all mechanical parts, so their arrangement is this. So boiler ru steam gala turbine, turbine condenser. So aim kari ame Carnot cycle anusare ame also you can theoretically you can have a plant, but it is not possible. But theoretical point of view, we have a reading to. Next is the temperature entropy diagram and pressure and volume diagram of the Carnot cycle. This is the Carnot vapor power cycle. This is the, I have already told there are 4 processes. 1, 2, this is the constant isentropic process. 1, 2, this is the 1, 2 constant isentropic, माने entropy remain constant, माने एटी हमर entropy अछि S1 is equal to S2. You can write also S1 is equal to S2. So that means constant entropy process. Compression process. Compression कहीं को होची ना temperature rise कला plus pressure भी rise कला. एटी देखो PV diagram corresponding एटी प्रेशर 1 रे थिला एटी 1 रे थिला बर्तमान 2 को गला प्रेशर भी बढ़िला एटी आम टेम्परेचर भी देखिले बढ़िला एटी T2 थिला T2 हैला एटी थिला T1 इनिशियल थिला T1 आम कैपिटल टी नौचे कहीं दे आर केल्विन आम सब केल्विन डिराइव करिया यूनिट इज केल्विन आर एंट्रोपी यूनिट तुम कहीदेली आर किलो जूल है हीट यूनिट बाय टेम्परेचर केल्विन तापर केजी स्पेसिफिक एंट्रोपी माने पर यूनिट मास किलो जूल पर केजी केल्विन पर केजी यार यूनिट है एटी से प्रेशर यूनिट तुम जानछ तो एटा यू कैन गिव आल्सो बार वॉल्यूम कैन दीज आर स्पेसिफिक वॉल्यूम मीटर क्यूब per kg volume unit. So look at this cycle diagram and this line your saturation line. This is saturation liquid line where dryness fraction is 0 and this is saturated vapor line where it is meeting point is known as critical point. This is your critical point. So this is saturated liquid mane only you will find liquid water. Here you will get water liquid. Here you will get vapor or steam. Steam dita phase रे तमरा काम करछि liquid टा एटी water convert होछि vapor को in boiler. So this is the diagram. Here is the pressure volume diagram. You see this is 1 2 तापर 2 3 रे हीट एडेड है सो वेयर हीट इज एडेड at constant temperature. So this means 2 3 your isothermal process एटी जो isothermal तार corresponding एटा isothermal process रे हम हीट ऐड कले by in कला हीट टू द बॉयलर तापर एक्सपांड हैला टरबाइन रे दैट इज 3 to 4 ए देखो एटा एक्सपांशन है ये प्रेशर रिड्यूस होती देख ये पटे आसला प्रेशरटा कमीगला पूरा P4 को पलैला ये प्रेशरटा P4 को पलैला ये आमर थिला P3 थिला